Okay, let's get started. Hopefully everyone can see my screen. Thanks again, everyone, for attending. We'll be talking about one of our products called Ansys Discovery today and sharing a customer story from Oxford Product Design. We will make a recording of this webinar available for those of you that do wish to share it with your colleagues. By way of introduction, I'm Rob Shropshire and I lead the sales and marketing side of Origin. I'll be running the session today and will be your point of contact moving forward should you wish to chat with us further. I'm really pleased to be joined by Neil today, who works at Oxford Product Design. I know he'll tell you a little bit more about the company, but Neil has a wealth of industrial experience and specialises in the modelling and simulation aspects of the work they do at Oxford Product Design. So once again, very pleased to have him on the call. I know for many, it often means a lot more hearing from a customer who uses the technology as opposed to the vendors themselves. I'm also joined by Tim, who is a director at Origin and does a lot of the training and support for our customers. So generally a day-to-day contact for many of them, and also gets involved a lot in terms of working with customers pre-sales and making sure that the solution meets their requirements. So we prefer that the session is interactive. There is the ability to ask questions throughout, so please ask away and we'll make sure we leave plenty of time for questions. I'm not sure we'll use up the full hour, so please ask questions or we can give you some time back towards the end. I will start off with a quick introduction. I won't talk too much, I promise, but just setting some context in terms of what we do and why we think Ansys Discovery is important. We'll then launch straight into that case study from Oxford Product Design, where Neil will explain how they've integrated simulation into their design workflow and also share an example with you. Tim's then prepared a demonstration where we can hopefully bring that customer story to life and show you how it's possible to iterate a design in real time using simulation. So at Origin, we have around 200 customers, all of whom are in the manufacturing space. I think what's unique about Origin is that we are focused on the design side and really advocating for simulation much earlier on in the design process. Of course, most companies perhaps do simulation in some form, or perhaps they outsource it, but it's often much later in that product development life cycle. So we believe that all companies should be informing design with simulation. They should go hand in hand. As well as providing the software, we also provide local support and training services here in the UK. And the product that we'll be showcasing today is from Ansys, and we're very proud to be one of their partners. All of the solutions that we provide do have a low initial investment, I promise, and they take a day of training to get up to speed on. So no matter what your company size is, we think that you should be able to leverage these solutions quite easily. So as I said, we are advocates really for incorporating simulation much earlier on in your design workflow. By allowing simulation to be done earlier, design engineers can explore multiple concepts very quickly and get to the best design much quicker by easily being able to test different designs and materials. So if they've got a couple of ideas, they can quickly find out which one is likely to be the best design for its intended use. They can avoid expensive prototypes, physical testing, and the time delay of getting simulation results back. So I must be clear here, the differentiator here is making design changes and getting results in real time. And we think this is different to quite a few other products on the market where the process of prepping a model for simulation and then getting results and then going back and modifying the geometry based on what you've learned is often a little bit slow and it's not so iterative. So these tools can often require a bit more training time, or perhaps it takes a bit too long to get results. So simulation isn't done as much as it could be if it was done in real time. So rapid simulation allows you to give designers the information that they need from the outset to help validate their design and thinking, as opposed to waiting towards the end of that development cycle to find out that the design might need amending. It helps designers get creative and innovate in a safe space, iterating their design in real time moving off standard solutions and towards innovation. Another interesting idea that I'm passionate about is just being better than your competition. A lot of people see simulation as a validation tool, which of course it certainly is, but it's also a communication tool. If you were a buyer and you were looking to source some consultancy work, and company A came to you with a model of a product, and they were able to iterate that design and show you various different types of simulations to show how that design or that product might behave in real life, I would argue that you're much more likely to pick that option than the company that perhaps just sends you a 3D model or directs you to their company website. So as well as being better, could you also add new service offerings around simulation to increase your footprint within your existing customer base? Perhaps those customers are actually going elsewhere for some of the services that you might be able to provide. So just a few points to cover off here. One of the challenges in adopting simulation is typically the skills required to learn them. And this is why traditionally only a select few are given the training and tools to run simulations. Some of you on the call will also point out that traditionally hardware and cost can become a barrier to adopting simulation. And because of this, you end up with a bit of a bottleneck. You end up with more designers and designs than you do simulation experts. And this means that you either don't do it, you either outsource it, or you have to simply wait to get the results back from your team. A lot of the time though, we find that designers don't always need to run complex simulations. They're just looking to validate their thinking, explore the geometry, the materials being used in their overall design. So by giving designers access to these tools, we not only free up simulations teams' time to do more value-added activities, but we also allow designers to iterate their design and test out more options, which we think leads to a higher quality product. If we look at the product development cycle, we all know that changes are more easily made earlier on. And the more design time that we sink into the product as we move through the cycle, the more money we spend on prototypes, the more money we spend on physical testing, it becomes much, much harder to change that design. So if we do simulation up front, we can hopefully reduce our product development costs and get the product out to market quicker. So 2 slides on discovery, and then we'll get across to listen to Neil. So in terms of what discovery is, it's an integrated product, a single license that integrates a direct modeler, which is a full drawing package, and combines it with FEA, CFD, and thermal analysis. Once simulations have been run, it's possible to perform topology optimization to further improve the part and hit objectives like reducing weight whilst adhering to the manufacturing constraints you might be working to in terms of whether it's machined or 3D printed, etc., etc. Discovery combines GPU-based simulation, or working off the graphics card, and CPU-based simulation, so users can switch between the software producing the mesh automatically or the user defining the mesh and reviewing the mesh before simulation. This is the first of its kind and allows both designers and simulation experts to use the software, striking the right balance between accuracy and speed. The product's also integrated with other Ansys products if you do require further validation in products like Ansys Mechanical and Ansys Fluent. So a final slide, and then we've got a few poll questions we want to ask before we get across to Neil. But let's just look at simulation and perhaps what the workflow might look like. So first of all, in Discovery, we need some form of geometry. So we can create the geometry from scratch using the built-in CAD package, or we know that for a lot of companies, you'll have your preferred CAD package that you're used to using, and that's absolutely fine. So you can bring in your model, and we support most file types, including CATIA, SolidWorks, Creo, NX, AutoCAD, and even STL and faceted data, and there are a few more as well. The direct modeler approach that is built into the product does, however, allow us to bring in a model and quickly defeature the model or simplify it for the purposes of simulation. We can then leverage the built-in materials database or create our own materials and then set our conditions and parameters for the simulation. Once we're at that point, we can then go into what we call the explore mode, which is where we let the software mesh the part in the background. We don't even have to defeature the model, and it can even run simulations on scanned or faceted data. So it gives you very, very fast results, allowing us to test multiple concepts as quickly as you can design them and iterate them. Once we think we have the right solution, if we want to, we can then switch to what we call the refine mode, which is where we'll follow a more traditional mesh-based approach to simulation and control the mesh ourselves. And again, we can access solvers from mechanical and fluent. So the summary here is a simulation product that caters for all of the different skill levels, but enables us to make decisions about how we use simulation. Do we need very fast results, or do we need to spend a bit of time meshing the part to get higher fidelity results? So we can sort of take into account actually who's using it and where we're at in that product development process to decide on how we use simulation. So just before we get over to Neil, I am just going to flash a couple of polls on screen, which you should see pop out. So if you could just let us know, if you can, whether you currently use simulation tools. I think that's always interesting. Some of you won't be using it. Some of you will have access to simulation within your CAD package. Some of you might not use it, but want to use it. If you can fill that in, that would be great. And the second question that I'll ask, which really depends on whether you actually use simulation, is whether you actually use it in your design process. So whether you're using it as you design, or perhaps just using it right at the end of that process. So I'm just going to leave a little bit longer, just in terms of results while we wait for those. Yeah, that's interesting. Over half of the attendees do have simulation, which is built into their CAD package, which is absolutely fine. Oxford Product Design have it built in too, but you use Discovery for other things as well. And some of you don't use it at all. So hopefully this will be very interesting for you. So with that, Neil, over to you. If you just want to start sharing your screen, and we'll let you know when we can see it.
All right, guys, you should hopefully be able to see that now.
Yeah, we can see that, Neil.
Smashing, thank you very much. Hi, nice to meet you. My name's Neil. As Rob says, I work for Oxford Product Design. I have done for longer than I like to admit now. And yeah, as you say, my job here today is to talk about how we use Ansys Discovery. Looking at the results of some of those polls, a lot of people are saying you have simulation tools already as part of your CAD package. So do we, but we are using Discovery on top of those, and in addition to those, and hopefully the reason why will become clear very quickly. What I would like to do first, however, is share our little marketing video that I've been told everybody needs to watch. What we do as a company is we help bigger companies who might have a certain amount of inertia to innovate. Our job is to come in and sit alongside your designers, your engineers, your managers, often quite a lot, and come up with things that are new and exciting and bold. That is challenging. A lot of people, especially in industries and in companies who have been around for a very long time, are quite resistant to change. And our big advantage, our speed and our flexibility, allows us to build confidence and comfort in a new, slightly riskier design quite quickly. First thing I would like to talk about is what is a design consultancy. Now I can see from the email addresses of a few people who are here, you have come from a few things. There's a few design consultancies in the chat there. Nice to meet you. But I can also see some heavy industry people in there as well. Now I come from heavy industry myself. I spent a long time working for Jaguar Land Rover in heavy industry, and while I was there I'd never even heard of a design consultancy. So what do we do now? As I say, when you work for larger companies, when you work for heavy industry, when you work for established businesses, innovation is challenging. Everybody says that they're innovative, but very few people actually are. Small, minor iterations of the same product, they're great, and your product will get slightly better slowly over time, but sometimes you need a complete refresh. Brand new products, breaking new ground, new technologies, new science, new user bases, new customers. These are all scary for big established companies, and people like us, people like design consultancies, are there to try and make that journey a little bit easier. We've worked with a lot of people. You'll recognise hopefully more than a few of the people on here. That list grows and grows and grows. I grabbed that list from a PowerPoint that's a couple of years old now. We are currently working on a refreshed website with our new CV almost, and we've got some pretty big companies in there who've benefited from having us help them out. You'll all be familiar with this. This is the standard product development roadmap. Anybody who's studied any kind of management or product development will be familiar with this. You start with research, then you figure out initial strategies to try and deal with a problem that you've identified. You start with sketching and industrial design, then you move through to engineering, prototyping, and iteration to really refine the result. So this is the standard product design roadmap. We're very familiar with this. Now, the way we do it at OPD is we look at it in terms of a relatively straight line. As you move down this line, things get clearer, things get more established. You're doing tests as you go along to give yourself confidence and move towards the solution. Now, what I've done at the bottom is I've added the different kinds of simulations that you might be doing at that point. So at the very end of the process, validation simulations, and nearly everybody does this. It might be part of your industrial standards that you have to do some simulations, physical or virtual. But it's also part of your liability cover. If you've developed a product, you want to make sure that it's not going to hurt anybody while on the market. You need to validate that. Simulations are very, very common there. They're also quite common in late stage development. So you have a product nearly there, maybe it needs a little bit of tweaking, or you've got a bit of a problem with some of the strength of the product, or the flow, or the temperatures, or something like that. And it's near the end of development, so you put some simulation into it and you tweak the product, it gets a bit better, and then you can deliver. Fewer and fewer people do concept simulations. Now, this is something I'm going to talk about a little earlier on, and then even fewer still do early stage research. Now, the reason for that is simulations, as Rob said earlier, are traditionally quite time intensive, are quite serious, heavy duty things that you tend to put off doing until you absolutely have to. And what I'd like to try and say is that that's not necessarily the case anymore. Again, I'll skip over this quite quickly because Rob already mentioned it. The earlier on you can do these simulations and you can learn from them and refine your concepts from them, the cheaper and quicker and easier this is going to be, and the more confidence you're going to have in the final design. Great example of that. We were working with a client who is a large established electronics company. One of the things they were working on was a desktop device that took a high power input and transferred it into a wireless signal. I can't be too specific about that because this product is only going to hit the market in a couple of years' time. So what I've done is I've anonymized the product ever so slightly, but this is a very, very true story. We had our industrial designers sketch up a few things about how the product could look. And as we presented them to the client, some of the managers within that client were very risk averse. They were worried that a completely new form factor, a completely new layout would have all sorts of problems with radio signals, but first and foremost here, temperature. They'd had experience in the past of the power demand that they would require going into a small desktop device, causing too high of a temperature and causing problems. So they were very, very reticent to try something new, a new user interface, a new design, a new kind of visual language for their entire family of products. They didn't want to innovate, they were afraid of it. So what we did was we took the industrial design's initial sketches, we chucked them into CAD, very, very simple, basic CAD, only took a couple of hours. We're not looking at fastener positions, we're not looking at tensile strength of any of the materials or anything like that. We're just putting the shape and the rough layout of the PCBs into our CAD software. When we were there, we could then take that CAD software and very, very rapidly throw it into Ansys Discovery. And when we did it, lo and behold, those worried managers were right. They have had experience of the transformers generating too much heat and causing the device to heat up. And we could replicate that in Discovery in no more than a couple of hours, start to finish, and that includes CAD. Well, that's no good. You know, our client has told us it's not possible. We can show them this picture and we say, yes, it's not possible. However, with some very, very quick modifications, we could say, but if we change the location of those PCBs and change the air path slightly, we can bring those external temperatures down to something much, 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 much more manageable. Now, what we're not doing here is fully defining the solution. I've still not put any fasteners in. I've still not put any real split lines or any draft angles or anything like that. We're not fully engineering the solution. What we're doing is we're spending a couple of hours convincing the managers of the client that, okay, yeah, there's going to be some problems, but we can solve those with a small amount of engineering effort. And what that does is it generates this confidence, not only in the fact that, okay, it's a new design, but it's not as scary as you might imagine, but also it generates confidence in us as a consultancy. It's, yeah, we know how to manage these situations. We know how to deal with these problems. So while you will have problems in development, and tell me somebody who doesn't have problems in product development, we can deal with that. We have the tools, we have the ability, and we have the knowledge and experience to deal with these problems as and when they arrive. And that level of confidence building has allowed these managers and allowed this client, who's a traditionally very, very static, not very innovative client, to come up with something really, really new in their space. So we're proud of this one. And when it goes public, we will put this one on the website. But it wouldn't have been possible without us being able to generate these images, generate these plots, and have that conversation very early on in the design process. Don't forget, this was all just based off the back of a single sketch and a half day's worth of work putting it into CAD. This wasn't a huge task to get this thing simulated. It took us a few hours, and then that meant we could unlock these conversations and unlock the further stages of development. So we're really proud of these ones. So I lost my mouse. Here we go. I just want to close it by saying that we would like you to get in touch with us and get in touch with Origin as well. If you're having these problems in your own organisations, with your own clients, So we don't just design products at Oxford Product Design. We are proudly a full service consultancy, and that includes having conversations with managers about managing risk, managing worry, reducing the unknowns in a project very, very early on. Innovation happens at the start of the design process. As a mechanical engineer myself, I tend to focus on the end goal where you've got all the screws in, the structural analysis done, and you're doing your ISO validation tests. But really, if you've started from a very static place, you're going to end up with a very similar result. So we use tools like this and conversations like this to help people innovate at the blank page stage of design, and we're very, very proud of that. So please do reach out and get in touch with us as well if you think we can help you with that.
Thanks very much, Neil. Yeah, I think that was really interesting. I think right at the start I talked about validation tools and communication tools, and I feel like in that example, very much a communication tool to sort of guide discussions with managers. I know that everyone on the call today might not be doing consultancy, but hopefully you can sort of see if you are developing products for your company that are going to be manufactured, that ability to perhaps talk to the management team about what those ideas are. Perhaps it's more in your case about iterating a design and testing multiple concepts out very, very quickly. So hopefully you sort of see the relevance of those sort of fast simulations earlier on. As I said, Discovery does allow for validation as well, so we don't want to undersell it, but certainly that power of fast simulation is really interesting for a lot of our customers. So what we're going to do now, I'm conscious, obviously Neil's very kindly shared an example. Obviously I had to desensitize it a little bit, but I think what we'll do now is actually show a demonstration that Tim's prepared, where we can actually take you through more of a live example. You can actually look at the software and you can look at the tool being used live. So hopefully you'll find that interesting. I will draw your attention, if you've not seen it already, there is a full screen button sort of at the top right hand corner. So if you do sort of have any problems looking at the software, then do click that. So with that, I will pass you over to Tim to start the session.
Hi everyone, thanks for joining us today. And again, it's always really interesting to see how customers are using Ansys Discovery for improving their product design process. So again, thanks Neil and Oxford Product Design for doing that presentation. So I'm going to be taking you through a real-time demo of Ansys Discovery that will give you a flavour of the power of the software for upfront design exploration. So we're going to be doing design exploration on a liquid valve housing. We're going to start with a CFD or fluid analysis on the flow characteristics of the internals of the valve. We can then use our geometry modelling tools within Discovery to make design changes and see how they will instantly affect the simulation. What we'll then do is actually explore potential different manufacturing methods. So maybe we're looking at manufacturing this part using an additive approach. So if we're going to be using an additive approach, maybe we've got a bit more design freedom, so we can take the values from our fluid simulation, in this instance the pressure values, to perform an FEA analysis on our part, and then use this to optimize and reduce the weight of the part using our topology optimization tools within Ansys Discovery. So first of all, I'm just going to open up the part. So this is the model that we'll be working with throughout our demo. So first of all, let's take a look at the internals of the model, just so we get a better understanding of what's going on. I'm just going to select on the axis and go into a section mode or a sketch mode, just to so I can see the internals of our part. So to better understand the internal flow characteristics of this valve, firstly we need to extract our fluid volume, and we've got a number of tools within Ansys Discovery that allow us to do this. One of them is in the Prepare tab, and it's the volume extract tool, a really powerful tool to extract volumes. And the second way is actually in our simulation tab to use our quick start guides, and here we can do internal flow or external flow. I'm going to be doing an internal flow, so we can use these quick start guides to very quickly extract a fluid volume as well. So the first step is to select your inlet faces or face. I've only got one face in this instance, but you can use multiple. And then I can select my outlet face. So once I've done this, my fluid volume will be created, which hopefully we can see here. And if we look to the left hand side, we can see what we call our physics setup. So these are all our conditions, so we can see our material that we're using. In this instance it's water. We can change this or create your own materials, but I'm going to stick to water in this instance because that's what it is. And then we can see our inlet and outlet conditions as well. So we can see we've got 0 pressure on the outlet. If I double click on the inlet, we can see here, we can change this to a mass flow rate, a pressure, swirling flow, and we can also work in different units as well, so we can see hopefully those there. For this instance, I'm going to leave these as the defaults. And once you've got your fluid volume, we look to the right hand corner, our solve button becomes available, and we can click the solve button, and within a few seconds we'll get some results. Because we're in the explore mode and that's using the power of the GPU, the graphics processor, we get results very, very quickly. So I'm going to hit the solve button now. Instantly as I click that, we get starting to see results. The simulation is still solving at the moment, and we can see this sort of bar going around here showing that it's solving. In a few seconds that will hopefully complete, which it has done now, and we can start to visualize our results. So at the moment we're looking at vector velocities. We can see this here. We can animate this, and that will potentially show us these sort of recirculation zones. There are other ways of viewing the results as well. We can look at contours, we can look at isosurfaces, we can look at streamlines, we can look at particles, and we can also look at direction field. So when looking at this, we can potentially see these areas of sort of recirculation in the model. One nice way to sort of view these is using our vector velocities. And here we have the option to sort of modify these. I'm going to increase the thickness slightly. I'm going to increase the count as well. Far too much, but let's increase the count slightly. And then I'm going to change it to magnitude. And actually, I only want to show these areas of sort of low velocity, so where these sort of areas of recirculation are, so we can start to sort of visualize these. And if I hit the animation, we can also hit the play tool and start to visualize these, so we can sort of see they're in these sort of corner areas, these low velocity sort of recirculation zones. To improve performance, we'd hopefully want to try and reduce these as much as possible. So now we know where these are, we can potentially use some of our modeling tools to make some design changes. So I'm going to look now back into this the vector, and I'm going to go into a design mode. So we can then start to make potentially some design changes and see what effect these have on our simulation. So using some of my design tools, I'm going to use the pull tool. I can then make a design change. So I'm going to actually increase the radius in this. We can actually type in a value, but I'm just going to manually eyeball it just for the purpose of the demo. But we can type in a value, but I'm going to just increase it. And as I increase that radius, we can instantly see the simulation sort of update, and we can see the effect of your modeling change has on that simulation, whether it makes it better, improves it, or makes it worse. So if I make a couple of design changes, as we make these design changes, we can also obviously monitor values. So pressure drop might be something that you're looking to monitor. And we can see here that making that first design change, we've seen our pressure drop decrease. So again, making another design change, let's do the same on this radius here, and just make another design change. And as you iterate your design, these values will update, and you can see the effect that the changes you have affects the model. So once that's done, we'll make one more design change, so we can see that making that change down there actually increase the pressure drop. So maybe that's not what you're looking for, so you can always undo or remove that change. Let's also see what happens if we actually modify the size of this sort of valve stem here. What about if we've got the opportunity now, because we're 3D printing it, we've got some different manufacturing options, so we've got a bit more design freedom. So let's decrease that again. I'm just making another design change, just so we can see as we're designing, we can validate our results and see actually what the effect is that we're having on this part. So we can see again how that changed. So maybe this radius here wasn't the best thing to change, but the other design changes would be okay. So once I've made these changes, and I've obviously studied this in a CFD example, my next step might be actually to optimize the design of this part. So what we're going to do now is actually take this part and make some changes to it and actually optimize it based on potentially the results you got from your CFD simulation. So now we're going to optimize our part for a new manufacturing process, in this instance additive manufacturing. So if we were going to 3D print this, at the moment this part's made up out of a few different components. We might be able to print this in sort of one component. So I've just first of all, I'm going to hide my volume and hide the internal component, because we're just going to be focused on the outer shell. So if we can print this out of one component, the first thing I might do is actually merge these three components into one. So I'm just box selecting them again using our modeling tools within Discovery, and I'm going to hit the combine tool and make that all one solid. So that's all now one solid. We could also potentially start to simplify and improve our design space. What this allows us to do is, if we simplify and improve our design space, it allows the software then to come up with the optimal load paths and optimal design locations to sort of remove material from. So to do this, we can start to use some of our Discovery modeling tools. Great modeling prep tool in itself. I'm going to just use the fill tool to get rid of radiuses, and then I'm going to use my pull tool, which is this one next to it, just to sort of increase these areas, so you can start to see making these changes. Just using my fill tool, I can start to get rid of rads that I don't want. We can make some more like sort of drastic changes as well. One thing I could do is potentially copy and paste this edge, and I'm then going to actually pull this area up. I'm going to specify a certain height. I'm going to pull it up to this height. I'm then going to use my fill tool to cap off this area, so this is all capped off now. And I'm going to do the same on the underside, so we basically end up with just a large cylindrical area here. So this is quite a drastic change, but this shows you the power of Discovery. We can then use our combine tool, which is might be known as a Boolean tool in other softwares. So this is my target. I'm going to chop it away from this one, and this allows us then to remove these areas. So we can see the what I'm left with is this. If I just hide my other one, we can see that it's now chopped around my solid, and I haven't got rid of the internals. So let's just turn these two back on. And then obviously, you know, if this is quite a drastic change, it might not be the exact what you want, but using the combine tool, then I can then merge these two together. So here we're just showing off sort of the power of Discovery's modeling tools as well, and how you can make very, very quick design changes to affect things. We've done a bit of model prep, and for the purpose of the demonstration, I'm just going to just sort of Blue Peter-esque this, show the one I created earlier, sort of my finished product, to save a bit of time. And this is my modified design now. So now we can start to run or set up our topology optimization. So first of all, I'm going to go back into my explore mode, and this is our fluid flow simulation. So I'm now going to actually create a new simulation, and we can start to set up our structural simulation and then turn on optimization. So the first thing I'm going to do is I'm going to start to select some fixed supports. So what I'm going to do is select on this hole here, and I want all these holes to be fixed supports. And rather than selecting them all manually, I can use what we call our power select. So I can select all the equal radiuses and all the coincident faces, and you can see how quickly I've just selected those. I can create name selections as well if I want to come back to those later on, and I'm going to specify those as fixed. We can add bolts and bolt preloads and all that, but for the purpose of the demo, I'm going to say that these are just fixed supports. So using my power select, I'm going to say that's also a fixed support, and then I'm going to just specify these faces as well, and they're going to be fixed supports. So once I've done that, I'm then going to apply a pressure to the internal fluid volume or fluid boundary condition. To actually extract that boundary condition, again, we can use another really powerful tool in Discovery. Again, we can go into selection, select using boundary. So this time I'm going to add a boundary. These are my sort of bounding faces. And then select a seed face, and that's any internal face. And now you can see we've just extracted that boundary, and to that boundary I'm going to apply a pressure. And obviously these pressure values could be taken from the earlier fluid simulations that we've done. I'm going to just apply a 200. I think that was one of the values I saw earlier, and then our setup is complete. So we can now do an FEA analysis on this part. So if we click the solve button now in the right hand side, we'll start to get results on our part, and I've just accidentally included too much in my simulation, so I'm going to just exclude those. So you can see on the left hand side what's included and excluded in your simulation, and all this shouldn't be included. So this is the only part that should be included in the simulation. So we can animate this, we can show how this part may behave. This probably will be over exaggerated. We can start to look at areas of stress on the part, factor of safety, these sorts of things, obviously important to designers. But once you've done that, and we actually want to reduce the mass of this part for potentially 3D printing, we can go into our topology optimization tab, and we can then set up our optimization targets. So first of all, we can choose what we're looking to do, whether it's remove excess material, maximize stiffness, all these sorts of things. So I might choose, in this instance, let's say remove excess material. We can choose how aggressive you want to be, so the target, and then you can also add manufacturing constraints. So if you are going to be machining this part, obviously we're going to be 3D printing it, so you might want to add a table direction or overhang prevention for 3D printing. If you're moulding this part, you can add your constraints. Also, I'm actually going to decrease our protected depth, that's protected area, so it will remove more material. So I'm going to say 0.3, and you'll see that this protected area then just decreases this pink area. So once I've got that set up, I can then start to solve my simulation. So if I hit the solve button now, so now that I've started the simulation, we will start to see material be removed from this body. We can start to see the areas of material removal, and this is based on our optimization settings and obviously our structural setup as well. Once your part has finished optimizing, we can then actually add the optimized body to the model, and we end up with something a little bit like this. The great thing about Discovery, again, the power of Discovery, what we're able to do is, one thing you can obviously do is straight away create a validation simulation on the optimized part, make sure again it is going to be it is going to pass and still be fit for purpose. But another nice thing is we can actually use this tool here called Smooth Facets, and it intelligently smooths the facets based on, again, all your supports and stuff. So it uses the geometry from the supports that you actually created in the first place. So you can see now we've got nice clean areas where these supports were, and let's just hide that. So we can see we've now got a much smoother part that may be more preferable to 3D printing. The areas where our internal geometry are, they are regions, still all these regions that we can. So if you want to go one step further and actually convert your now STL back into a solid format, we can do that again just using your right click, convert to solid, using surfaces. Within a few seconds you'll end up with a result that looks like this. So this is now a solid format that can be modified. For one, just to show you, I am changing the size of a hole. Obviously you might not want to do that in real life, but shows that we can obviously modify the data, any internal data that we need to, because this is CAD data, and then we've got the more organic optimized structure on the outside. So hopefully this demo has given you a bit of a flavour of the power of Discovery, and I'll pass back over to Rob now. But if you have had questions, or you do have any questions, feel free to put them in the chat box, and we'll try and answer those now.
Thanks, Tim. Hopefully you can all hear me again. So hopefully you found that demonstration useful. I know we covered a fair bit, but we I guess kind of wanted to showcase the flexibility there in terms of the types of things that you can do. I've only got 2 more slides, so if you did have questions, start typing them in now, because there will be 5 or so minutes for questions at the end. But just by way of summary, hopefully what you've seen is a tool that is relatively easy to use and quick to pick up. I think what we've seen a lot of there is the software doing the work in terms of meshing the part for us and giving us results very quickly. But do just bear in mind that full mesh controls are available. So there might be some simulation experts on the call today that perhaps have to do sort of final validation. So again, you are able to select from sort of local mesh settings for particular areas of the part. So you can do all of that. And remember, it does allow you to access products like Fluent and Mechanical under the hood. So you've got all of that flexibility available for you. Hopefully what you've seen is that it does, I think it's important that software looks nice and is easy to use. Hopefully what you've seen is a relatively modern user interface, which is relatively easy to pick up. And finally, hopefully what you've seen is a fairly sort of robust and complete package. Discovery is fantastic for businesses that might want access to simulation. They want it at an affordable price. They want to be able to grow with the simulation product and perhaps add things on down the track. But the fact that it comes with that drawing package, it comes with the ability to bring in your CAD models, it comes with the ability to defeature models. You can edit, change geometry, and get results very quickly, and do all of the main types of simulation that you'd expect from a simulation package. Once again, that being FEA, CFD, thermal simulation. You can also mix and match as well. One of the things we haven't mentioned today, because it is very new, is electromagnetics is also now available in the product. So it is something that's got a relatively aggressive roadmap. Just finally, if you are wanting to sort of engage further with us, you can do so. We can do a tailored demonstration. Usually that sort of involves maybe even looking at one of your parts, taking you through the process of setting up the simulation, so you can sort of explore your own design, something that makes sense to you. And typically, a free trial is often requested as well following that, so there is the opportunity to test the software out and make sure it meets your requirements. Often that's the best way of getting a business case approved is by being able to say that, you know, you've looked at it, you've reviewed it, and you're happy with the results that you're getting. And building a business case as well, you know, we can help you with that as well. You know, if you know that you know simulation would benefit your business, but you're struggling to justify the cost, you know, we're more than happy to help you through that process. Here are our contact details on the screen. I've popped Neil's email address on there as well. If you did have questions for him, you can call me on the mobile or call Tim as well. So all there and happy to talk.